Hey y'all, this is Elijah Johnson and this is Physics 1 Lab 5. So this lab focuses on understanding what happens to the bottom of the slinky when the top is released from rest while suspended. We analyze this both experimentally and through simulation using GlowScript. The key takeaway is that the bottom of the slinky remains motionless until the top section collapses onto it, at which point the entire slinky falls together like a single object. Fundamental physics concepts like gravitational force, momentum principles, and Newton's second law play a significant role in understanding this behavior. So, momentum principle is where an object's momentum is its mass times velocity. Gravitational force is representing the downward force due to gravity. And then Newton's second law states that an object remains at rest or in uniform motion unless acted upon by an unbalanced force. And net force is where tension cancels out the force of gravity at the bottom of the slinky initially. So the system setup have the system as the slinky in the earth. Surroundings was everything else like ground, air, and people watching. Initial conditions: mass was 0.2 kilograms, and initial position was 0.04 meters, which is like the bottom of the slinky. The bottom of the slinky stayed motionless until the top collapsed onto it. This happened because the net force acting on the bottom was zero. Tension upward canceled gravity's downward pull. Excuse me. Once the top reached the bottom, the whole slinky fell together as a single unit. Any discrepancies in scaling, like using the 0.04 meters instead of 0.04 meters in tracker, had no significant effect on the analysis. The initial conditions were variables for mass, position, and forces. First while loop.
Hey.
Hey.
I'm leaving.
Okay. We're gonna fitty there.
You're gonna fetty?
Yeah.
Awesome. Okay. I just saw Jacob upstairs.
Okay, cute. Okay, so the first while loop simulates the bottom of the slinky before the top reaches it, during which the net force at the bottom remains zero. The second while loop simulates the entire slinky falling as one mass after the top reaches the bottom, resulting in a non-zero force. Note that the spring was mistakenly used instead of slinky in the code. Fixing this across the code was skipped since it didn't impact functionality or results. And then our analysis of the top graph experiment showed the bottom of the slinky staying motionless initially, then moving up once the top catches up. And the bottom graph, which is simulation, mirrors this behavior, but shows some slight differences. So the first discrepancy was delayed motion in experiment. So tracking started slightly late, making bottom appear to stay still longer. And the second one was final position in simulation ends below zero due to ignoring air resistance. Conclusion: This experiment demonstrated how fundamental physics principles govern the motion of a falling slinky. The bottom remains at rest due to balanced forces until the entire slinky collapsed into unified motion. While the simulation closely matched observed data, small deviations were caused by practical limitations like tracking delays and simplified physics models. Thank you.